Hi, my name is Tina Niemi, and I'm a professor in the Department of Earth and Environmental Sciences at the University of Missouri in Kansas City. It is my pleasure to record this greetings to Tzvi ben Abraham in honor of his 80th birthday. It's been over 30 years since I first met Tzvi. I was a graduate student at Stanford and was invited to come to Tel Aviv University to work on some seismic reflection of the Dead Sea. At that time, there was just one shack on the roof of the geophysics and planetary science building. And that's where I used a Gerber to measure the depth of, in milliseconds, of each of the reflectors. I did come back in 1992 to 1994 as a postdoc. And by that time, the roof had turned into a penthouse with a multitude of students, including Margaret, Ori, Meir, Vladimir. And I had a office down on the department floor. Tzvi always was working on a paper. It's amazing. His publication record is so prolific. He taught me so much about how to conduct research, how to write papers, and how to get them published and to turn them around quickly. We worked together to make a conference on the Dead Sea, and the outcome of that was The Dead Sea, the Lake, and Its Setting, a book published by Oxford University Press. About 3 years after I left my postdoc in 1997, it was published. I also had the opportunity to do some coring in the Dead Sea, and do some 3.5 kilohertz seismic reflection imaging. This was in 1993 with the CellCore program. And I came back in 1999 to watch the submarine get launched and go down, although I did not actually go on one of the dives. Thank goodness, I'm quite claustrophobic. Our research collaboration continued into the 2000s. We got our first Middle East Regional Cooperation MERC project for the Gulf of Aqaba for geophysical imaging, including multi-channel seismic reflection, magnetics, and gravity, and onshore GPR. And then a second round of funding in 2010 for coring and more seismic reflection. This started a multinational, multiple-year research program in the Gulf of Aqaba, Gulf of Eilat, that included several PhD students and master's students and many papers that are even now still being published. The second MERC project, we were aboard the Mediterranean Explorer, where we had group meetings, as you see here. Gal Hartman did a lot of the geophysical seismic image processing and collection. And the team had a good marine geophysical season and some onshore trenching to go with it, and onshore GPR. These studies, these collaborations have opened up multiple collaborations with many different universities and many different people. And I am forever in debt for Tzvi for his enthusiasm for conducting research, for great ideas, and getting big groups together to solve interesting problems. It's with much thanks that I also thank the Israel Academy of Science for organizing this event and invited me to contribute. I was first just going to record a greeting and a thank you to Tzvi for all of his mentorship, collaboration, and friendship. But in the later correspondence, I was also asked to actually give a lecture. And so this is what I'm going to do now. I'm going to move into the lecture. I was asked by Tzvi to give a lecture on the bottom currents at the Natal Valley offshore of South Africa. And to be honest, I published this paper 20 years ago, and I had to go back and reread it to remember all of the interesting things that we said in that paper. But South Africa is at an amazing place in the ocean circulation system where the Indian Ocean and the Atlantic Ocean meet, and waters from the Pacific get shuttled all the way over to the Western Indian Ocean. And those currents come down in what's called the Agulhas current, a warm surface current that curves back around and then heads back towards the east. These currents are important in today's modern global warming scenarios because the temperatures of the ocean and the transfer of heat directly impacts the climate that we see on various continents. So these are the surface currents. The RV Professor Logachov is the research vessel that SVI coordinated to come from St. Petersburg, Russia in April of 1992. I was in Tel Aviv at the time, and I was originally scheduled to be on this marine cruise, but a month or so prior to the cruise, I was told that there wasn't space, which actually made me a little sad, but I did end up working on the data later. So over 3,740 kilometers of high resolution seismic reflection data were collected with both Sparker and air gun in the Transkei Basin and the Natal Valley off the southeast coast of Africa. I did get to go to South Africa. I went to the University of Cape Town. I think it was in February of 1993 for about 2 or 3 weeks, working at the University of Cape Town with other collaborators. I also got to see the Cape of Good Hope, Table Mountain, and there's an image there of Don't Feed the Baboons. It was an extraordinary time and an exciting visit for me. And I got to work on some of the data from the offshore southeastern African coast. Now, if we review the thermohaline circulation system, which is also called the global ocean conveyor system, it's how surface warm waters circulate and bottom cool waters drop down deep within the ocean and then upwell at various locations. So it's actually a conveyor belt or a circuit. And you can see that there are various places that are nexuses. And one, South Africa, is the place where warm currents travel westward and cold currents travel northeast. And if we were to look at a cross section of the Atlantic Ocean, you'd see that the water bodies are stratified, that very cold water from the Antarctic subcontinent sink and make what's called the Antarctic bottom water. They're the densest water. Waters also upwell in the North Atlantic that are cold and very saline. That becomes the North Atlantic deep water. Then we have the intermediate water and the warmer surface current, like in the Atlantic, which is the Gulf Stream. And so we'll be looking at the Antarctic bottom water and evidence for the North Atlantic deep water evolution off the southeast coast of Africa. This is an image of the bathymetry, and you can see South Africa. We can see what's called the Agulhas fracture zone and a passageway, a narrow passage between the continent itself, the continental shelf, and the Agulhas plateau. This is called the Agulhas passage. Cold waters funnel in through this, the Antarctic bottom deep waters funnel in there. And then we have the shallower basin of the Natal Valley, and then the abyssal plain that's called the Transkei Basin. And then another ridge, that's the Mozambique Ridge. So because bottom currents are moving very rapidly and they're cold and acidic, they tend to erode the ocean floor, but they also entrain turbidite sediment from the coastline, making the base of what's called a contourite, which is made by these geostrophic bottom currents. These mounds are also called drifts. And so the base of a drift sequence will have a uniform reflection pattern with a regional disconformity. We could see that these contourites form at the base of the slope or in the middle of the abyssal plain, as you can see with this Agulhas drift that was imaged by this particular studies data set. So I'm going to show you some lines. Here we are. This is the area of southeast South Africa with the Natal Valley and the Transkei Basin. The Transkei Basin is at abyssal depths greater than 4.5 kilometers. Here are the seismic reflection lines, and I'll show you a section here and another section parallel to the Natal Valley, offshore Natal Valley. So here we have drift. This is the Orbee Drift. The Orbee Drift is buried, so it's a relic drift. This relic drift actually follows the continental slope. And then we could see these regional reflectors that we called in this paper. The oldest one is at the Oligocene-Eocene boundary, O, middle Miocene is M, and then the P is the Pliocene. We can also see the Mozambique Ridge with its moat system, very deep erosional moat and buried system of the ridge, also likely active. This activity on this ridge, we hypothesized that in one paper may have caused this current that was causing the Orbee Drift to shut off. Here's another cross section. This one's from the northeast to the southwest, showing various other drifts that we have. The modern drift that goes from the Pliocene that's above this erosional reflector P is called the Agulhas Drift. And then there's remnants of a drift over here in a higher, shallower bathymetric depth, in which we call the M drift. These are likely middle Miocene in age, based on correlation of reflectors across the Indian Ocean and into the Cape Basin and drill core data that we correlated to. Here we have from Margaret's paper, we have the Agulhas Drift and the Agulhas Plateau showing active faulting going all the way up to the seafloor. And then deeper penetration with seismic processing showing us the Cretaceous tertiary boundary and our lower Cretaceous reflectors. And this is a blow up of this migrating crest of the Agulhas Drift or contourite. So if we look back at the ocean in the Eocene, there were some very dramatic different conditions. We could see that there was an equatorial current, a warm equatorial current because the Tethys, where the Mediterranean is, hadn't closed, and Panama, North and South America hadn't closed. So there was a warm equatorial current, and the Drake Passage here, this critical gateway, hadn't opened up either. So we don't have Antarctic, the Southern Ocean, actually the cold waters around it, and we just get the incipient beginning of Antarctic glaciation. So if we look at the map of the different drifts that were seen on the seismic reflection data, we see that the Oligocene, the Eocene drift follows the continental shelf. Then there's a dramatic shift with the unconformity of the M reflector, and the drift changes its orientation to an east-west orientation with the current flow, which is the proto-Antarctic bottom water flowing here towards the east, coming up through the passage, maybe triggered by uplift along the Mozambique Ridge. And then finally, this stops at the drift, or the bottom current, the Antarctic bottom water shifts to deeper water, and we get also erosion along the shelf. So we know now that by the time of the P reflector, which is Pliocene, that the Antarctic, the North Atlantic deep water was stratified and pouring into the Indian Ocean around the Agulhas Passage. So this is the story that we came up with the seismic reflection data. These are the papers that I was involved with, the first one coming out in '94 while I was actually doing my postdoc. Took another 6 years for me to actually process all the data and get the paper published that I just spoke to you about. And then Margaret also published a paper then in 2005 on these seismic reflection data and the gravity and the magnetic anomaly data. So this was groundbreaking work showing the different circulation changes that you could identify by the changing location of the drifts that were imaged by the marine program that went out in 1992. Well, I hope you enjoyed that short introduction to ocean bottom currents around Southeast Africa and the Natal Valley. I do want to thank the Israel Academy of Science for inviting me to give a greeting and to give a talk on our work in South Africa. And I want to give a special thanks to Tzvi for all of his mentorship, for being a colleague for more than 30 years, and the exciting work that I've had the opportunity to do with him over these years, and a very happy 80th birthday. Thank you.